Hi, year 11. In this lesson, we're going to be looking at compound measures. Last week, you spent your time looking at a compound measure in a sense of looking at speed, distance, and time. And remember, the word compound measure just means a combination of two measurement units being put together and, in a sense, bringing you a new measure altogether. The ones we're going to be focusing on within this lesson is mass, density, and volume. Can I just remind you as you go through this lesson, where you have any opportunity to show your working out, please show your working out, please attempt all tasks, and please make sure you complete the final reflection task, which is on the very last slide. In terms of the keywords that we're going to cover within today's lesson, compound measures are just measures that are made up of two or other measurements. We then got density, which is a key thing that we're going to be looking at. I like to think of it as the thickness um, of an item, potential item, but it says here it's the amount of mass within the volume. It tells us how tightly matter is packed together. What I want you to make sure that you've done is that you've taken down the definition of density, and we've got here density is the amount of mass in a volume. It tells us how tightly matter is packed together. You've then got common units that you will see when we're talking about density. So you could have grams per centimeters cubed, kilograms per meter cubed. I want you to think about this problem for a minute. It says here, which is heavier, a kilogram of cotton wool or a kilogram of rocks? And I want you to think about that and come up with an answer within your head before you move on to the next slide. Now, if you think about 1 kilogram of cotton wool, 1 kilogram of rocks weigh exactly the same. They weigh exactly the same. And if you thought the rocks were heavier, well, what you're actually thinking about in your head, you've got this preconceived idea that the rocks are thicker, so they're going to weigh heavier. In other words, what you've actually thought about is the density in that respect if you thought they were heavier. And so a much more sensible question might be to ask, well, let's say we took the same size, so let's say we took the same volume of our rocks on our feathers, so 1 centimeter cubed, and you can look at the example that I'm referring to is on the right. We took 1 centimeter cubed of cotton wool and 1 centimeter cubed of rock. Which one would be heavier? Well, we should get the rock, and that, in a sense, is density. That is showing us how density acts in real life. Now, if you did the lesson on speed, distance, and time last week, well, this week we've got another triangle, formula triangle, and it's all to do with mass, density, and volume. M stands for mass, D stands for density, V stands for volume, and they work the same way. If you want to work out something, you cover it up, and then you look at what's left. And usually the questions are nicely set out for you in the sense that whatever you cover, you've got the two things that you need to mathematically operate with. If we look at this example, it says here the standard gold bar has a volume of 714 centimeters cubed. That's our volume. It says it weighs 12,000 grams. That is our mass. So what is the density? Well, if we cover our finger over D in our formula triangle, well, it means we need to get our mass of 12,000 and we need to divide that by a volume of 714. And if we do that, we should end up with 16.8 grams per centimeter cubed. Right. Please make sure you don't get the units confused. The units are just as important as the final answer in terms of your numbers. Your units do matter for every question that you answer. When you do eventually answer questions, I'm expecting to see this kind of working out before you give me a final answer. Suppose instead we have a question that says a standard removable box of length 40 centimeters is filled with feathers. So the density of the feathers is 0.0025 grams per centimeter cubed. So what is the mass? Right. What they haven't done here is given us a volume. Right. We're thinking about a cube here. A cube, remember, has all equal lengths, so you can work out the volume very easily by doing 40 times 40 times 40. Right? If you're wondering where that 64,000 came from, well, that's just the volume, but they've used the idea and the fact that a cube has all equal lengths. If one length is 40 centimeters, well, it's 40 centimeters going all the way around that cube, right? And you can work out the volume by times your length, your width, and your breadth, the thickness of the cube, to work out your volume, which is where that 64,000 centimeter cubes come from. Now, if we look back at the question, it wants us to work out the mass. If you cover the mass, well, you then need to do density times your volume, and if you do that, you should get 160 grams per box. After you finish all the tasks, I want you to open the answer document that's attached to this lesson. I want you to assess your performance, mark your work, and then tell me how you feel about your understanding of mass, density, and volume. Tell me what you found difficult and tell me what you found straightforward. Please make sure that you've shown all your working out. Please make sure that you've completed all tasks. Please do not be lazy. Right? You don't need to answer two questions. The first question is it a sponge more dense than a brick? You don't need to have a go at the problem below, right? Which is asking you to work out what is the volume and the mass of 1 million in £10 notes. Right? I've done a bit of the working out for you. I've actually worked out the volume for you and it's right there. So you just need to do the last part of that question and work out the mass using your formula triangle. Once you've done all of that, please upload your work on Show My Homework and I'll be able to give you some feedback and comment on how you've performed. Thank you very much, yeah,